This video is about an introduction to R. R is a language and environment for statistical computing and graphics. It provides a wide variety of statistical and graphical techniques and is highly extensible. Now, why do we have to use R? First, it's because it's an open source application, meaning it is free. Unlike any other statistical applications which may cost you a lot, you don't have to pay anything for you to use this app. Another thing is that it's available in Mac, Windows, and even Linux. Next is that R has large community of users which enables sharing of newly developed statistical technique. So if one developed a new statistical techniques and he wanted to share it with others, he has to build what we call a package, and that package can be shared to everyone. Last is for programmers, the use of R is very user-friendly as the coding used in this app is very much similar to other programming apps like C, C++, Fortran, and others. Now to download R, go to Google and search for CRAN space R. Once the results are out, go to Comprehensive R Archive Network. Or simply go to http://cran.r-project.org. Once you're on the website, simply choose your operating system as Windows or Mac. If you're using Windows, click Base or click Install R for the first time. Either of the links will lead you to a window that displays the latest release of R. Click Download R for Windows, save the installer, and then install R. If you're using Mac, look for the latest release, click that link, save the installer, and then install R. Once R has already been installed, you may open it and you may begin typing. Just note that R is a command-driven application, meaning you have to type everything, and that codes are caps sensitive. Now let's begin typing. Type 3, then press Enter. It results to 3. Now try 3 plus 1. Press Enter. It will give you 4. How about 5 minus 2? Press Enter, and of course it will give you 3. 4 times 3 or 4 asterisk 3, it will give you 12. And for division, 12/5, it will give you 2.4. Now you see here that R may be used for arithmetic calculations and even exponents. Let us try 5, caret sign, then 2. And it will give you 25. Now how about 12, double percent, and 5? It will give you 2. What's that for? Let's try another one. 40, double percent, then 6. It will give you 4. Now how about 34, double percent, then 9? The result is 7. Double percent is actually the modulo operator, which gives you the remainder when the first number is divided by the second number. So 12 divided by 5, the remainder is 2. 40 divided by 6, the remainder is 4. And 34 divided by 9, the remainder is 7. Now how about 40%/%6? The result is 6. How about 34%/%, and 9? The result is 3. Now that operation denoted by %/% is what we call the integer division, which gives you the quotient regardless of the remainder. So it simply disregards the decimal value of the quotient. Now let's try logarithmic functions. Type log, then in parentheses a number. Let's say 5. Press Enter key, and you will get 1.609. Now 1.609 here is not the same as the log 5 when you get your calculator, because the log function in R is actually the natural logarithm. So if you get your calculator and try ln 5, that is the same in R as the log parenthesis 5. Now the logarithm function in your calculator is the common logarithm, which in R is log 10, then parentheses. So if you'd like to try, let's say, log 100 in your calculator, that is log 10 parenthesis 100 in R. And you will get 2. It's basically because 10 squared is equal to 100. Now let's try creating a data set. The format is an object name, whatever that is, then less than, then dash. Which from now on, let's call this combination of less than, then dash as an arrow, because it is simply like an arrow facing left. Now, this tells R that an object of that name will contain whatever it is on the tail of the arrow. Suppose we're going to assign a set of numbers and consider that set of numbers as an object, that arrow shall follow C, which stands for concatenate. Then those numbers shall be inside the parentheses separated by a comma. So let us try A, arrow, then C. Then in parentheses, let's put some numbers. Let's say 19, 25, 32, 27, and 41. Then press enter. Then as you type A, then enter, the values in the parentheses will be shown. Now this shows that R was able to consider a data set which is called A, having the numbers 19, 25, 32, 27, and 41. Let's try another one. Let's say an object which is named B. Then arrow, then concatenate, which is C, then in parentheses 1, 2, 1, 2, 3. Then close parentheses, then press the enter key. Of course, those values will be displayed. Now let's try another object, let's say C, then arrow, then A plus B, then enter. Now press C and then enter key. And now we see the values containing C, which are simply the sum of the elements of A and B accordingly. So that's 19 plus 1, which is 20, 25 plus 2, which is 27, and so on. Now let's try another object, let's say D, then arrow, then B minus A. Press enter, press D, then enter, and it will display the values of B minus A, which in this case are the values of B minus the values of A accordingly. So 1 minus 19 is negative 18, 2 minus 25 is negative 23, and so on. Now let's have another object, let's say E. Arrow, then this time let's make use of the function abs. So that is ABS, then in parentheses, let's put D. Close parentheses and then enter. And then type E, then enter, and it will display the values of D in its absolute form. So basically, the abs function expresses all the values in that object in its absolute form. Now let's try another function, let's say length. So that is length, parentheses, then let's take the object A, then close parentheses. And then press the enter key, and it will give you the result, which is 5. The length function here refers to the number of observations, in which in statistics, we often refer to it as the population size if the data come from population, or the sample size if the data came from samples, which are denoted by capital N or small n respectively. Now let's try sum, parentheses A, and the result is 144. So obviously what R did here is to add all the values in object A. Now if we try sum, parentheses A, slash length, parentheses A, obviously this gives the mean of the values in object A, which in this case is 28.8. Further, you may assign another object, let's say mean underscore of underscore A, to assign the sum of A divided by its length. Now note that that arrow, which is the combination of less than and dash, may be replaced by equal sign. So if you're not comfortable with using less than dash or the arrow, then you may use the equal sign. So meaning whatever we typed a while ago, all the arrows may be replaced by equal sign. It is because, again, that arrow is the same as the equal sign. However, the programmers of R and the frequent users of R do not actually use the equal sign, because the equal sign is usually used for the logical functions, which are not part of this video. Now let's try to calculate some descriptive statistics in R. Suppose a researcher gathered 5 random patients with anemia and their age are 19, 25, 32, 27, and 41. And suppose we're asked to find the mean age of these patients. In case you have noticed, these values are the same values in our object A. And by the way, in case you'd like to recall all the codes that you have submitted, simply click this button above and it will show or hide the R command history, which contains all the codes that you have submitted. Or you may take the easiest way by pressing up, because pressing up will display all the codes that you have submitted previously. Anyway, continuing where we are, let's compute for the mean of the values in object A. That is mean, parentheses, A close parenthesis, then press the enter key. If in case we may assign another object, let's say EX1, to be another object but has the same values as in object A. So trying mean, parenthesis, EX1, gives us the mean of the values in the object EX1. So you don't actually have to type sum EX1 slash length EX1 to get simply the mean of the values in EX1 because mean is a built-in function in R. So the mean age of the patients with anemia in this case is 28.8 years. Now how about the median? That is median parenthesis EX1. And that gives the median of the values in the object EX1. So in this case, the median age of the patients with anemia is 27 years. How about mode? Let's try mode parenthesis EX1 close parenthesis then press the enter key. And obviously that is not the result that we are looking for. So what we may do to find mode is to make use of the table function. So we may type table parenthesis EX1 and it will display all the distinct values in the object EX1. And below that are the number of times that each value appeared. So as we know, mode is the value or the observation with the highest frequency, and all the values here appear just once, then the object EX1 doesn't have mode. Let's move on with the measures of other position, also known as quantiles. And R was able to document 9 ways of computing quantiles. SPSS and Minitab have the same way of computing quantiles, and that is type 6 in the R documentation. And that is also the same way I computed quantiles in my previous video. So we will use type equals 6 every time we use the quantile function. So let's try to compute for the quartiles. Let's say quartile 1. So that is quantile, parenthesis, the object name, let's say EX1, comma, and then probs equals C, parenthesis, and then the quantile that we're looking for. Since we're looking for quartile 1, we have to make use of 0.25, close parenthesis, comma, and then type equals 6, close parenthesis, and press the enter key. So the first quartile of the age of the patients with anemia is 22 years. If let's say we want to compute for the 70th and the 75th percentile, simply we make use of the quantile, parenthesis, EX1, comma, probs equals C, then in parenthesis 0.70, comma, 0.75, close parenthesis, comma, type equals 6. And that will give you the 70th and the 75th percentile in object EX1 using the formula type equals 6. So in this case, the 70th and the 75th percentile are 33.8 and 36.5 years respectively. Now what happens if we do not include the probs option in the quantile function? Let's say we have quantile parenthesis EX1, comma, type equals 6, close parenthesis, and press the enter key. R will give us the 3 quartiles, which are quartile 1, which is the 25th percentile, quartile 2, which is the 50th percentile, quartile 3, which is the 75th percentile, together with the lowest observation, which is the 0th percentile, and the highest observation, which is the 100th percentile. Now moving on, let's have the measures of variation, starting with range. And that is range, parenthesis, then the object, let's say EX1. Close parenthesis, then press the enter key. And R will show us the minimum and the maximum observations, in which in this case are 19 and 41. So if in case you'd like to get the difference of those values, simply type 41 minus 19 and you will get the unique value of range, which is 22 years. Now let's proceed to the next one, which is variance. And variance in R is the function VAR. So that is VAR parenthesis EX1. Close parenthesis, then press the enter key, and it will give you the variance of the values in the object EX1. Just keep in mind that the variance unit of measurement is the square of the original unit of measurement. So if these are the age of the patients expressed in years, the variance of the age of the patients is 68.2 years squared. And that's the reason why we have the standard deviation, which is the square root of the variance, so that the unit of measurement is maintained. And in R, standard deviation is the SD function. So if we try SD parenthesis EX1, that will give us the standard deviation of the age of patients with anemia, in which in this case is 8.26 years. Now let's try to compute for the descriptive statistics in a real-life data, meaning a data that you may have encoded in Microsoft Excel. Then we're going to compute for the descriptive statistics using R. So first things first, how to import data from Microsoft Excel. First, it is advisable that you save your Excel file in tab-delimited form. So use File, Save As, and in the file format, choose tab-delimited because it is easier to import a data in R if the file is in .txt tab-delimited form. Now to import a file, you see in my desktop a .txt file and an Excel file for me to demonstrate both ways of importing the file. Now suppose I have the data in desktop and I want to import first the .txt file. And to do that, assign an object name first, let's say sample1. And in Mac, the format is object name, let's say sample1, then arrow, and then read.delim, then in parentheses, followed by quotation marks, tilde, /desktop, / the file, let's say sample1.txt. Read.delim here stands for read delimited file. Similarly, in Windows, use the read.delim function after assigning the object name, let's say sample1, arrow, then in parentheses and quotation marks the complete path of the file like c:/users /user/desktop then the tab delimited file sample1.txt. Now for importing an Excel file, we have to install first a package which is called readxl. Note that a package is a collection of functions and datasets developed by other users. And to install the readxl package, we must type install.packages and in parentheses and quotation marks readxl. And after downloading the package, we must install it using the library function. So we type library parentheses readxl. Note that in library, we do not use quotation marks. So for Mac, we start with an object name. Let's say sample1, arrow, read_excel, and then in parentheses followed by quotation marks, tilde, /desktop, / and then the file name .xlsx, in which in this case we have sample1.xlsx. And in Windows, we follow the same format starting with an object name. So that is sample1, arrow, and then read_excel, then in parentheses and in quotation marks the complete path like c:/users/user/desktop /sample1.xlsx. To check if you were able to import the file successfully, all you have to do is to type the object name, let's say sample1, then press the enter key. Now this data is a laboratory test results of 800 patients or 800 cases, in which the variables are, we have the ID, which stands for identification number, so you will see a number from 1 to 800. And then we have the age of the patient, which is in years, the gender, in which 0 is female, 1 is male, the lab test results, which are cholesterol, triglyceride, HDL, LDL, VLDL, and let's say the occurrence of a specific disease, like let's say chickenpox and then measles. 0 there means never, and 1 means the patient has already experienced having either chickenpox or measles. To take a look at the structure, we use str and then sample1. So what's this for? This will tell you whether the variable is considered as a numeric or an integer. Now the problem here is that you notice that the gender is interpreted as numeric or integer. Likewise, chickenpox and measles were interpreted by R as numeric or integer. But we know that gender, chickenpox, and measles are supposed to be categorical. These are not numbers. 0 and 1 are just codes to represent something. These are not quantities. So to classify properly the variables, which of those are numbers and which are really categorical, we have to change how are interpreted those variables. So specifically for gender, chickenpox, and measles, we have to change it to a categorical form, and we call it as factors. So gender, chickenpox, and measles are supposed to be factors. Again, simply because they are categorical variables. So to do that, let's start by changing gender. So we have to use sample1 $, gender. Now what does this indicate? Now this shows that the variable gender, which is in the file, which is sample1, will be converted to a factor, meaning to a categorical variable of the same data and the same variable, and using the labels female and male. Again, the variable gender, which is in the sample1, so note that the file name or the object name and then $, and then the variable name will be converted to a factor or categorical variable under the same name with labels female and male. Now, the question is, can this be interchanged? It's not. It's because you have to put first the one with the lower code. In this case, female is coded as 0 and male is coded as 1. So that's why it appears first, female first, and then male. So let's try that. Now what happened? Let's take a look at the data. Let's try to view the data. So type sample1. Now you see now that gender has values male and female instead of 0 and 1. So let's do the same thing in chickenpox and measles. Now note here that chickenpox and measles used never first and then experience. Again, it's because never is coded as 0 and experience is coded as 1. So that's why you have to put never and then experience. Again, it's because the one with the lower code has to appear first. So we see that gender, chickenpox, and measles are now labeled properly. And if we're going to take a look at the structure, gender, chickenpox, and measles were not anymore numerical or integer, but rather they are now factor, with 2 levels, meaning 2 possible responses in each category. So once done, these data are now ready for analysis. So first, let's try to compute for the mean. Let's say you're asked to compute for the mean of the total cholesterol. So to do that, let's use mean, and then we have to put the file name, which is sample1, and then $, and then the variable that we're trying to compute. In this case, cholesterol, which is chole. The answer is 4.43705 or 4.44 unit millimoles per liter. Now how about, let's say, median? You're asked to compute for the median of HDL. So that is median, sample1, $, and then HDL. So in this case, we have a median HDL of 1.25 millimoles per liter. Now let's try mode. Mode of the total cholesterol. So again, there's no function that is mode. So what we may do is to use table, sample1, and then chole. Okay, so these are the distinct values and their corresponding frequency right below it. So we may see that 1.06 appeared once, 1.39 appeared once, 1.54 appeared twice. Now, all you have to do is to take a look at the value with the highest frequency. Now, if you're having a hard time the answers are actually 4.30, which appeared 20 times, 4.70, which appeared also 20 times, and 4.90, which also appeared 20 times. Those are the values of modes. Now, if you're having a hard time to find it, suppose you have a larger data set, we may use table, then let's assign a name, let's say T. Then take a look at its result. So still, that's the same result. And then, let's convert it to what we call as data frame. So in this case, what R will do is, the table will be converted to a data frame and R will name it as call a table. Now, let's take a look at call a table. So notice here that what R did is basically it arranged the data set and then its corresponding frequency. Now, still, you may have a hard time looking for the mode using that. So the easiest way is to arrange the frequency from highest to lowest, so that whichever are on top, those will be the modes. So let's try to do that. In this case, we're going to sort the table again from highest to lowest based on the frequency. So let's name that as call a table 2. So what R did here is that the table, which is the output a while ago, will be sorted descendingly and convert it again to a data frame so that it will be arranged vertically. We may try to take a look at the result and just scroll the result upward. Now it's more clear that 4.3, 4.7, and 4.9 have the highest frequency, which is 20. So those are the values of modes. Now, let's proceed now to quantiles. So suppose you're asked to find the first quartile of LDL. So all we have to do is to type quantile and then sample 1 $LDL and then probs equals C 0.25. Then don't forget to put type equals 6 if you want to make use of the same formula again used by SPSS. So that gives us 2.02 millimoles per liter. Now, how about 60th and 75th percentile of age? So all we have to do is to replace LDL with age and then replace 0.25 by 0.60, then comma 0.75. So this will give us the 60th and 75th percentile of age. So we have 39 as the 60th percentile and 45 as the 75th percentile. Now, for the measures of variation, let's try to find the variance of triglyceride. So that is simply var and then sample 1 $sign and then trigly. So that is 0.139 or 0.14 millimoles per liter. Don't forget the unit of measurement. Again, variance is squared, so millimoles per liter squared. For the standard deviation, let's say of LDL, so that is SD sample 1 $sign VLDL. So answer is 0.17. Again, millimoles per liter. Now, what if you're asked to find the counts? How many? Let's say, how many patients have had chickenpox? So to do that, it's simply use table. So the answer is 674. So again, the table is used for counting. So that's what you have to remember. Next, how about If, for example, you have to split the results, let's say the average of a certain variable, but you have to split the result, let's say by gender, you have to take a look at the mean, let's say, of male and female. So to do that, we have to split according to factors, and we have to make use of the function which is aggregate. So aggregate will separate the result according to a categorical variable. Let's say you're asked to find the mean age of female patients. Now, to answer this, you have to separate the mean age according to gender. So applying the aggregate function, so aggregate parentheses, you're going to start with the quantitative variable, the one that you're going to compute for the mean, in this case, age. And then we have to make use of the tilde. It means according to gender. So you have to put tilde and then gender. And then the file name and then the measure, let's say mean. So that will display the results of the mean age of both male and female. So keep in mind that you have to make use of the tilde symbol or the curl. After that is the categorical variable. And then the file name or the object name and then the measure. So answer is 36.47. Now let's try, let's say, the median LDL of male patients. So how do you do that? So aggregate, then the variable you're going to compute, in this case LDL, according to still gender. Sample 1 and then median, which is the descriptive statistic that you're going to measure. So that will give us an answer which is 2.62 as the median LDL of male patients. How about percentile? So we're going to make use of quantiles. So we're going to make use of still aggregate, then triglyceride, which is trigly, according to, since we're asked only of those with history of chickenpox, so we have to split the result according to those who had and who have not experienced chickenpox. Then comma, then the file name, and then how about the quantiles? We have to use FUN equals quantile. And then the usual, like probs, equals C, 0.55. Then again, if you want to make use of the same formula as the one used by SPSS, type equals 6. So in this case, the 55th percentile is 1.4. Now, how about if the question is, what is the mean total cholesterol of female and with history of chickenpox? So only those female who have had chickenpox, what is their mean total cholesterol? So how do we do that? So again, aggregate, and then the variable, in this case cholesterol, then the tilde, and then gender, since we're asked for the female. How about those who had chickenpox? All we have to do is to put plus and then another variable, let's say chickenpox. So this will separate the result according to gender and those who have had chickenpox or not. Then the file name and then the descriptive measure, in this case mean. So the answer is 4.45 millimoles per liter. How about if the question is, how many? But of the male cases who have had history of measles. So we are sure that we're going to make use of table. But if we're going to make use of sample 1 $sign measles, this will only give those who have experienced and those who have not experienced measles. How about we're going to split by gender?
all we have to do is to put an additional variable, sample1 $sign gender. So this will separate the counts according to those who have and who have not experienced measles according to gender. So it will simply make a what we call a cross tabulation. So here we see that the answer is 201 patients. If you'd like to save your work, just go to workspace and save workspace file. And then choose the file name, let's say sample data. Then put dot and then R data so that it will be recognized by R eventually. Then click save. Note that this just saves the data file, which is sample1 that we worked with a while ago. So you don't have to import the file again. That doesn't save all the codes that you type. So remember, to view the codes that you type, we have to click this icon on top, which is show or hide our command history, for you to view all the commands that you typed a while ago. You may also see this even if you turn off your computer.
I hope you learned the basic statistical features of R through this video. You may click like, you may also subscribe, and you may comment down below for feedbacks and suggestions. Thank you for watching and stay safe, everyone.